Okay, class, welcome to day 6. We're going to work on some word problems and how we can do some applications, including using the calculator. So first of all, let's talk about what is area of a circle using as a function of a radius. Well, that's your basic formula of A equals pi r squared. You've done that many times in your life. How about if we want to write it as a function of the diameter? Well, diameter equals twice the radius, so the radius equals 1/2 the diameter, and I can substitute that into the problem. A equals pi, not r squared, but 1/2 d squared, so A equals pi 1/4 d squared when I distribute the square to both of them, and when I'm done I get pi d squared over 4. So if I know the diameter instead of the radius, I could just plug it into this formula and you would get the same result. And then finally, what happens if I know the circumference? Well, circumference of a circle is 2 pi r. So r equals c divided by 2 pi. And I got to substitute this in. So a equals pi, not r any longer, c over 2 pi squared. I distribute that squared, c squared over 4 pi squared. And I multiply it through, and one of the pi's will cancel, and I get a equals c squared over 4 pi. So if I happen to know the circumference of a circle, I can figure out its area. So this next problem is the activity that we did on Friday, where we cut out the corners out of an 8x10 piece of cardboard and we fold it up and make an open top box. So I set it up already where I have all the x's listed out. And if you recall that this side will now be 10 minus 2x when you cut out the corners. And this side will be 8 minus 2x when you cut out the 2x's from that side. So if you recall, volume is length times width times height. So for this example, it's going to be 10 minus 2x, 8 minus 2x times x, and I tend to put that single x up front. 10 minus 2x, 8 minus 2x. And this is the equation that formulates the volume of that open top box. So then I have to figure out the domain. And we talked about this. So what is the largest value for x that can be cut out? That was a question I asked last time, and we discussed it that it's always half the shorter side. So for this case, the domain is 0 through 4. And then how can I do all this? Well, I'm going to put this on the graphing calculator. So I'm going to use my graphing calculator and put this in there like I did on Friday. So here's the, I put it into the graphing calculator. I don't expand it out. I don't multiply it out. I just leave it with the parentheses and the x's like they are. And then I set my window. And I'll put this down on the piece of paper in a minute, but my domain are the x min and max, 0 through 4. My range are the y's, and I do -10 because I do want to see the x-axis, and I go up to 100, and then I hit graph it, and I see what the graph looks like. And then I have to find the max value. If you recall how we find a max value, we do second trace, number 4, and you can use the arrow keys to go to the left side. You can use the arrow keys to go to the right side. Well, I know it's around here, so I'm going to use 3. I can just type in 3 and hit enter. And then what's my guess? I'll just say 2 is my guess. And it actually gives me a result. As you can see, this where the X is blinking, that is the maximum value for this graph. Now I'll put this all on the piece of paper to see what's going on. So here's a summary of what I did on the calculator. I put the y1 as the volume equation. I set my window. and I graphed it, and I found the max by doing a second trace, and my results are the maximum volume is 52.514 cubic inches when x equals 1.47 inches. So I set up the problem already. We have a satellite dish that is really the profile of a parabola, and I want to put a piece of cardboard cylinder inside of it for protection. And I drew it out, and since the width is 24 and the height is 6, this point way over here is 12.6. So I'm trying to figure out the height, this pink height. Well, if the cardboard is 12 in diameter, that means this is 6. The y value I don't know yet, but I can use that to figure out the height. Well, all parabolas that have the center, the vertex through the origin, is y equals ax squared, and I know I have the point 12, 6. I could plug this in here. So I have the equation y equals 1 over 24x squared is the general equation for this parabola. Well, now for the piece of cardboard, I know I have x equals 6, and I can plug this in. 1 over 24 times 6 squared, so y is equal to 1.5. So that point here is 6 comma 1.5, and I could do the height, which is the top 6 minus the 1.5, so my height is 6 minus 1.5, so my height is 4.5 inches. For that 12-inch diameter cylinder that I want to put inside, I need a height of 4.5 inches. So for this example, it's a shoe manufacturer, and cost is what it costs to make shoes. So each shoe costs 30 plus 100,000 fixed costs, so C equals 30x plus 100,000. Revenue is what you make every time you sell a pair of shoes. So in this case is R equals 50x. The break-even point is when R equals x, so 50x equals 30x plus 100,000. 20x equals 100,000, or x equals 5,000 pair of shoes. Now let's see what the graph would look like. So when I plot these two equations, the C equation and the R equation, I get what they look like this, and right here at 5,000 is the break-even point, and everything past the break-even point in this area, this would be my profit for this equation. Okay, for this next word problem, chemistry class, mixing two acidic solutions together to get a total of what we want. Well, I make a little graphic organizer chart here to help me figure it out. So the first solution I know what it is, I just call it A, but it's 25%. And then the second solution is B, and that's at 45%. And the grand total I know is 20 at 31%. So how do I get what's the pure acid? Well, to figure this out, I take this and I multiply across. I multiply across the rows. So the first one, just 0.25A. The second one is 0.45B. And the last one, 20 times 0.31 is 6.2. So how can I use this to figure out equations? Well, A plus B is equal to the grand total of 20 liters. In the last column, I do the same thing. 0.25A plus 0.45B is equal to 6.2 amount of pure acid in that solution. So this is Algebra 1. Use my systems. I can use substitution or elimination. I like elimination better. I'm going to multiply this by negative 0.25. I get negative 0.25a minus 0.25b is equal to negative 5.0. Put them together, I get 0.20b is equal to 1.2. So I get b is equal to 6 liters, and therefore going back, the grand total is 14, that A must equal 14 liters. And that's how I do that problem. So again, I use my little chart here to figure out my two equations, which are always the first column and third column. I wrote them out. I like using my elimination method. I'm going to use negative 0.038 as a multiplier, negative 0.038a minus 0.038b equals negative 456. And I get 0.014a equals 112. So A equals $8,000, and therefore B must be $4,000 because I had a total of $12,000 to begin with. Okay, this next problem is drawing a rectangle under a parabola. So right now you can see this parabola here, right here, and I could draw a rectangle underneath it. I could draw lots of rectangles underneath it. I could draw this skinny rectangle. I could draw this big wide rectangle. I could draw many, many rectangles, okay? So how would the area of this rectangle be a function of the value x? So I'm going to erase all this. Where area is base times height. Well, the base is this whole bottom side here. So if this is x, this whole base is 2x. So my base is 2x. Now the height is this side right here. Well, the height is just whatever my y value is, the vertical length there. But I have an equation for that y, and that is y is equal to 16 minus x squared. So my height is equal to 16 minus x squared. So area equals 2x times 16 minus x squared, or 32x minus 2x cubed. Either one will do. Doesn't really matter to me. Now I have to figure out the domain. What is the domain? Well, the farthest this rectangle go out is right here at this x-intercept, and this x-intercept is equal to, this x-intercept is equal to 4 by doing 0 equals 16 minus x squared is equal to 16, x equals plus or minus 4, but obviously it's the positive one. So my domain is again 0 to 4, just like the problem we did before. Why is it 4? Because this is the x-intercept. So now I'm going to put this on the graphing calculator to see what it looks like. So I put it in the graphing calculator, and I just did it the first equation, the 2x parentheses 16 minus x squared. You want to write out the 32x minus 2x cubed? Doesn't matter, they're the same. My window, I think I'm going to keep the same window as before. 0 to 4 for sure is the domain. And let me try to see if the range goes up to 100. So I hit graph. I see the graph of that function, and 100 was enough. You can make it small if you want, but I think this was good, so I'm going to do second trace, number 4. Looks like right here at 2 is where, or right here around 2 point something is where the max at. So I could use my arrows, or I could just type in 1 for the left side of the boundary, sets up a fence. I can go 3 for the right side of the boundary, sets up a fence, and for sure the max is somewhere in between those two dotted lines. I'm going to guess 2. And there we are. There is that, where that blinking X is, that is the maximum value. When X is 2.31, I have a Y, which is the area, of about 49.3. So here's my sketch. Here are all my details. My Y1, the window that I chose, is actually the same as last time. So I have a max area equal to 49.3 square units. when x equals 2.31 units. So this is how we're going to use our calculator. Now, in a couple months, we're going to do exactly the same type of problems, but we're going to use calculus to figure this all out. Okay, thank you for watching the video.